All right, today what we're going to talk about is different ways of factoring quadratics. Some of this is going to be a review, so we're just going to get right into it. So first, as a review, you can multiply linear factors. So you've probably heard the term FOIL before. It means first, outer, inner, last. That's just a little trick to remember. I just say distribute all the terms and then combine like terms at the end. So just remember, you take your first to the first, take your outer to the outer, and then I take the inner terms, and don't remember that's a -3. So -3 times x, and then -3 times +4. Then once you get all your terms, then go ahead, combine any like terms, and then you can just bring the rest down, and then that is your distributing. I'm going to go ahead and have you try these. So just remember, you take the first term to both of the other terms, then take your second term in this to both of the others combined like terms. All right, and then another thing you need to remember is greatest common factor, or GCF. It's a factor that all terms have in common. So it's the reverse of multiplying. So instead of multiplying or distributing, you're dividing the terms by it. So if you're to look originally, ignore these, if you're to look originally at 3x squared plus 6x, they both have a 3x in common with each other. So what we're going to do is we're going to divide each term by whatever that is, and that's going outside the parenthesis. Then whatever you divide, so when we divide 3x squared by 3x, all that's left is x. And then here, if you were to take 6x divided by 3x, all that's left is 2. And then make sure you have parentheses around it. So the outside is your GCF, and the inside is whatever's left over. All right, so same thing here. You have to look at all of your terms, and they all have 4 in common. So if you're to divide each term by 4, the GCF goes outside, and everything else that's left over goes inside. So 4x divided by 4 just gives you 4x squared. 8x divided by 4 gives you 2x. And then 4 divided by 4 gives you +1. All right, go ahead, try this one. And this, you will have some numbers, and you will potentially have your x and a y as a GCF. So think of what all the factors they have in common, and that is your greatest common factor. All right, next up is difference of two squares. Now notice you have a difference, so difference means you're subtracting of two perfect squares. So always look for the greatest common factor first, and then check to see if both terms are perfect squares. So if you notice, a squared minus b squared, well, it's a difference. So since we have a difference, so far so good, and then this is squared and that's squared, so we're good to go. So what you do is you take your first term and you put a plus sign in the middle, and then you take the second and you put a minus sign in the middle. So hint, even exponents are perfect squares. So if you were to have x to the 4th, that's really x squared and x squared. And then x to the 18th would be x to the 9th, x to the 9th, and you can go from there. All right, so quick thing, this is not a difference of squares, and it's actually prime. Because if you were to take this term, a lot of people want to say it's a squared plus b squared. It is not that. Because if you were to distribute, you're going to get this, which is not a squared plus b squared. So let's look at this first one. This is a perfect square. This is a perfect square. There is a difference in the middle. 81's a perfect square. And then since that's an even, this is also a perfect square. So we're going to take this, take basically the square root of this, and I get 2g and 2g. We're going to take this, and we're going to make that 9h. So we're taking the square root of both terms, and 9h. And then you make one a negative or minus and one a plus, and then you're good to go. And we can't break it down anymore. All right, now this one, you do have a GCF, so we have to factor out the GCF first. So once we factor that out, we're left with x squared minus 9. Now this is a different of squares because this is even, and then that's a perfect square. So again, we're going to take this, take the square root of this, and you're going to get x and x. And then we're basically taking the square root of 9, and you get 3 and 3. And you make one sign plus, the other side, or negative, the other side plus, and then don't forget to bring down your GCF. So this is your final answer. All right, go ahead and I want you to try these two. Remember to look for GCF first. All right, another review is grouping, and you need to have 4 terms. So always check for greatest common factor first, and then pair up any terms into pairs. And we're going to take the GCF out of both pairs. Then we kind of divvy them up from there. All right, so what we're going to do is we're going to group this part, and we're going to group this part. So looking at just this part, the GCF is x squared. And then what's left over is x minus 2. And now we're coming over to here. Well, the GCF is 4, positive 4, and we're left with x minus 2. Now we're going to take whatever is the GCF and put it together. And then whatever was in the parentheses, and we're going to put it together here. Now notice this is not a difference of squares because it's got a plus sign in the middle. So this is as low as you can go. All right, so how you choose to group this is up to you. You can group it this way, and this way is what I would suggest. And then go ahead and factor it all the way down. So go ahead, try this one. All right, now we got trinomials. Oops. If you have a coefficient of x is greater than 1, it's always going to be ax squared plus bx plus c. Where a is less than 1, you can use grouping or guess and check. Truthfully for me, I just do guess and check unless it's one that I already know. Some of you may already know this because you've done the X game. There is just one trick. You need to multiply a times c. So then once you go through, you multiply a times c. Then you have to figure out what adds or combines to give you b. So in this case, it's negative 15, but multiplies to give you 36. And that would be negative 3 and negative 12. So then you just break this up into negative 3 and negative 12 and bring everything else down and then solve from there. So we're going to use the time to practice. All right, this first way is just the guess and check. So it says do GCF first. You're going to draw 2 sets of parentheses. And then you're just going to write factors of the constant in the last place. So here I've got negative 2 times 1. And, oops, sorry. I meant to put 6. I looked there. I looked the wrong place. So looking at negative 6, we've got 2 and 3. So it could be either 1, or it could be 1 times negative 6, or it could be negative 2 times 3, or 2 times negative 3. So we're looking at these, and then which one, in this case, we're going to have a positive 3 and a negative 2, so we're going to use this. And then we're just going to break this guy up, and it's pretty easy because this is just 5 and 1. So then we just kind of check to see, using FOIL, do we get what we started with? And if the answer is yes, then we're good to go. All right, so I just kind of did this one here. Is first I'm going to factor out the GCF, which is 3. And then I'm going to take the leading coefficient, which is 6. And I'm going to break it up, or sorry, leading coefficient, which is 2. And I'm going to break that up into 2 times 1. And then I'm going to take my constant. Well, 3 is pretty easy. It's just 3 times 1. So then I just have to figure out which way will work to get the best method. And you can always double check at the end by doing FOIL, and then don't forget to multiply 3 times everything just to check to see if you got what you started with. All right, now you don't have to use guess and check, but I want you to at least try doing this problem. So guess and check is just taking your factors of the leading coefficient and the constant and then seeing which one works. All right, now this you can use any method. But I want you to go ahead and I want you to try all of these, but remember to always look for GCF first. So make sure you're looking at that for all of those. All right, Another way, which is more, I think, what you will probably remember as trinomials, is to do the x game. So when you're doing the x game, I always just remember it's a times c. So remember, a is going to be 1 in this case. A times c is 12. And then it needs to combine to give you b. So then 7 will break up. Oops, looks like my eraser got too many there. Okay, so it looks like in this case, 7 is going to break up into 4 and 3. So 4 and 3 multiply to give you 12 because you have 1 and 12, 2 and 6, 4 and 3. So we said 4 and 3, so we're going to go ahead and go x plus 4, x plus 3, and that's it. All right, same thing here for number 3. If you were to look what a times c is 16, but it needs to combine to give you 10. So when you're thinking about it, you could do 1 times 16, 2 times 8, and then 4 times 4. So different ways, but in this case, 2 and 8 are going to fit to add to equal 10. So we're going to go x plus 8, x plus 2, or if you did x plus 2, x plus 8, it's fine as long as you've got that. All right, and then here is the trick. Look for GCF. So remember, I'm going to take 3 out of each term, and then I'm left with this part. Now, we're going to go 1 times 9, which is AC, but it needs to combine to give you -6. So when you're doing this, I know it's going to be x and x here, but for -6, it's got to be -3 times -3. So in that case, x minus 3, or, so either of those would be correct. All right, I want you to go ahead. I want you to try all that. And then that is a review on how to factor quadratics.